Cambridge IGCSE Physics May June 2020 Paper 4 from Question 6 to 10. Question 6. The speed of sound in air is 340 meters per second. Part A. Calculate the range of wavelengths for sounds that are audible by a healthy human ear. The frequency that humans can hear is from 20 Hz to 20,000 Hz. This needs to be memorized. They asked us to find the wavelengths, so we calculated using the formula wavelength equals to the speed of sound over frequency. 340 over 20 equals to 17 meters, and 340 over 20,000 equals to 0.017 meters. So the range is from 0.017 meters to 17 meters. Part B. Sound waves are longitudinal waves. Describe how a longitudinal wave differs from a transverse wave. For longitudinal waves, like sound waves, their vibration direction is parallel to propagation or the energy travel direction. But for transverse waves, their vibration direction is perpendicular to propagation or the energy travel direction. Also for longitudinal waves, they consist of rarefactions and compressions. You need all 3 points for a full mark. Part C. Figure 6.1 shows a band in front of a building. The drum produces a low-frequency sound. Other musical instruments produce a high-frequency sound. These sounds are equally loud. A young man at the side of the building hears the drum but not the high-frequency sounds from the other musical instruments. Explain why this happens. So what's the reason why this person cannot hear the high-frequency sounds but only low-frequency sounds? The first thing that you need to notice is that this person is not standing in a straight line from the source of sound. In order for the sound to be heard from him, the sound waves will need to diffract. It is extremely important to mention this word. Okay, so when the sound diffracts, the lower the frequency, like the drums, the greater the wavelength. And if the wavelength is greater, there will be more diffraction of sound, and the person will be able to hear it from a distance. But since high-frequency sounds have smaller wavelength, it will not diffract and you won't be heard. Question 7. An electromagnet consists of a solenoid axe that is made of copper wire. The solenoid contains an iron core. Part A. Explain why the structure of copper makes it a suitable material for the wire. What are the properties of copper that allows it to be used as a wire? Well, copper contains free electrons since it's a metal, and it is a good electrical conductor. Why iron is a suitable material for the core of an electromagnet? Since they're making an electromagnet, it needs to be a magnetic material, and iron is one of them. Also, as easily as it is magnetized, it is easily demagnetized as well, so it carries a property as a temporary magnetic material. Part B. Figure 7.1 shows the electromagnet inside a second solenoid Y. Inside solenoid Y, there's another solenoid X, terminals of Y here, and iron core. Describe and explain what happens in solenoid Y when solenoid X is connected to an alternating current AC power supply. It's an AC power supply, so with the solenoid, alternating magnetic field will be produced by X. Due to this, there will be an electromagnetic induction in Y, and as a result, the alternating electromotive force, the EMF, produced in Y. A switch and a lamp are connected in series with the terminals of solenoid Y. When the switch is closed, the lamp lights up to normal brightness. Describe and explain what happens to the current in solenoid X when the switch is closed. Imagine what would happen if they put a switch and a lamp here in series. The current will flow from this power supply around the circuit. With the lamp switched on, it will require more power in solenoid Y. So what would happen in solenoid X? The current in X will have to be increased in order to supply the power used in the lamp. Question 8. The power supply used in an electric vehicle contains 990 rechargeable cells, each of electromotive force EMF 1.2 volts. The cells are contained in packs in which all the cells are in series with each other. The EMF of each pack is 54 volts. Part A. Calculate the number of packs in the power supply. Each pack is 54 volts and one cell is 1.2 volts. So that means in one pack there are 45 cells. In total, they said they have 990 cells, so with 45 cells, you can have 22 packs. Part B. When in use, each pack supplies a current of 3.5 amperes. Calculate the rate at which each cell is transferring chemical energy to electrical energy. This might be a little confusing since it's that transferring energy, but all you need to do is to find the amount of energy produced. Power equals to EMF multiplied by current. EMF is 1.2 volts and current is 3.5 ampere. The answer is 4.2 watts. The packs are connected in parallel to supply a large current to drive the electric vehicle. Explain why it is necessary to use thick wires to carry this current. Firstly, the thickness of the wire is always related to the resistance of the wire. Thick wires have smaller resistance, so it's more efficient in carrying the current. Also, if there is less resistance, there will be less heat produced in wires, so there will be less risk of fire or insulation melting. Question 9. Describe how a digital signal differs from an analog signal. You may draw a diagram. So for digital signals, they consist of high and low voltages, like this diagram. But for analog signals, the voltage is continuously varying like this. Part B. In the appropriate box, draw the symbol for an AND gate and the symbol for an OR gate. Easy mark if you remember the symbols. This is the AND gate and this is the OR gate. State how the behavior of an AND gate differs from that of an OR gate. Well, when you put two different inputs such as 0 and 1, for AND gate, 0 will be produced, but for OR gate, 1 will be produced. Part C. An arrangement of logic gates A, B, and C is shown in figure 9.1. The arrangement has two inputs, X and Y, and two outputs, P and Q. Output P of logic gate B has logic state 1, high. Determine the logic states of the two inputs of logic gate B. So you got 1 at P, and logic gate B is a NOR gate. It has this small circle in front, and the outcome will be opposite of an OR gate. In order to get 1 from a NOR gate, its input should be 0 for both upper and lower input. Determine and explain the logic state of output Q. Let's first identify what is logic gate A. It's a NAND gate, the exact opposite of an AND gate. Since it's supposed to give 0 to logic gate B, as you have found out from the above question, both of its inputs should be 1. That concludes that X is 1, and from the above question, we have found out that this is 0. So the upper input of logic gate C is obviously 0. Logic gate C is the NOR gate, so if you put 0 and 1, it becomes 0. Question 10. Figure 10.1 represents a neutral atom of an isotope of element X. Part A. State one similarity between this atom and a neutral atom of a different isotope of element X. Now it doesn't matter what this diagram looks like, you just need to know the similarity between a neutral atom and an isotope. An isotope is an atom with different number of neutrons, but same number of protons. So just write that a neutron atom has equal number of electrons or an equal number of protons. Part B. The isotope of element X is radioactive. It decays to form an isotope of element Y by emitting a beta particle. Using figure 10.1, deduce the nuclide notation for the isotope of Y produced by this decay. During my question, yes, you need to show the working of radioactive decay. First of all, count the number of protons and neutrons of element X. 5 protons and 8 neutrons, so it's X, 5, and 13. You write the proton number below and nucleon number above. Next, beta particle is basically an electron, it's -1 and 0. No protons or neutrons, just an electron. Okay, so you subtract this beta particle from X because it said it's emitted, and as a result, you get Y. Y will have 6 protons since 5 minus -1 is 6, and the number of nucleons remain the same. Beta particles ionize the air they pass through less strongly than the same number of alpha particles, suggest why this is so. You need to know the properties of beta particles in detail in order to answer this question. First of all, beta particles have charge of smaller size. Alpha particles carry 2 protons, so it is able to ionize more strongly, and also this makes the beta particles to have smaller mass. Beta particles have less energy as well, and being light, they can travel faster, so there is less time spent near to air molecules. That is the end of this paper. If this video helped you, please like and comment on my video and don't forget to subscribe. Thank you for watching. Stay tuned for more IGCSE past paper videos. Stay safe and God bless you guys. Bye!